Can see if I have distributive property. Do I have distributive property here? Yeah, I do. What's the clue that I've got distributive property in here? Those parentheses, right? So the first thing, oops, that's the wrong color I wanted to do. So first thing, I'm going to abbreviate. Are we okay if I abbreviate distributive? We all know what I mean when I say that. Dist. Okay, so what's my clue? And if you're a color coder like me, there's plenty of highlighters and stuff in your baskets too. All right. So, listen, I know, but okay, but you can, yeah, that's fine. You can type. All right. So my first clue that I'm doing distributive property. Sorry for kids that I just yelled who are going to be watching this at home. Sorry about that scream. Okay, y'all don't do anything that's going to make me go, ah! Okay. There's like 30 kids quarantined that are going to be watching this later, so shh. Okay. So, first things first, we need to distribute. When we're distributing, are we adding, subtracting, multiplying, dividing? What are we doing when we're distributing? We're multiplying, exactly. So we are going to take that 2. Remember, variables are a little bit racist. So the x plus 3 will not combine, and they're stuck there in the parentheses. So we got to multiply that 2 to get them out of there. So 2 times x gives us 2x.
No way.
Then 2 times 3
6.
Gets us a plus 6, right?
Yes, sir.
So our next step is that we need to look and see, is there anything that we can simplify? Can we make this a little bit more simple? Is there anything we can combine on the same side of the equal sign? Anywhere? First of all, can we combine that? Can we combine an x and a 6? No. Can we combine anything over here? Yes, because we have x's. We've got 3 x's, which we're going to take away 1 x from. So 3 x's, take away an x gives us, how many? If we had 3 and we took away 1, 2x. And then I'm going to bring down the 4. So this is where I'm hoping the shortcut comes in for those of you guys that were doing level 3. Because a lot of you guys went all the way through and solved this problem. But actually, there's a shortcut. Because if you look at this equation the way it's written right now, something's a little bit bajiggity about it. Okay? Here, we've got the same number, write this down, please, of variables. And what do I mean by that? We have 2 x's in this case, so I'm going to put that in parentheses, on each side, right? So we've got the same number of x's, but they are paired up with, what are they paired up with? They're paired up with different numbers, aren't they? So with a 6 and a 4. So I've got a little picture I'm going to show you in a second. So we've got 2 x's on both sides, but they're paired up with different numbers. Is it okay if I'm going to slide over for a second and show you a picture? Here's a picture of 2x plus 6 equals 2x plus 4. Look, you've got 2 x's. So there's 2x plus 6 because you got 2 x's and you got 6 ones. This is 2x plus 4. Is that balanced out? Of course not. Why not? They both have 2 x's, but you got 6 over here and you only have 4 over here. It is physically impossible for 2 x's with a 6 to balance out with 2 x's with a 4. The one with 4 is going to be lighter. It is impossible to balance. Therefore, this equation doesn't make any sense because we have the same number of variables on both sides, but different numbers to go with it. So this is a case of an equation that has no solution. A lot of you guys probably would have done this, where you solved, you don't have to write down what I'm writing right now. But I'm just trying to show you a little bit of a shortcut. A lot of you guys probably subtracted 2x from both sides, and got 6 is equal to 4, like did that extra step. And either way, and you were like, oh, well, that doesn't make sense. Okay, either way, it doesn't make sense. So so if you wanted to cancel out the variable on both sides and you got a false equation, either way, you know it's not true. That is an equation that cannot be solved. So if you have the same number of variables, so in this case, we've got 2 x's on both sides, but they've got different numbers to go with them, that is an equation that can't be solved because the one with the 6 is always going to be heavier. So this is an equation that has no solution. So anytime you distribute, combine like terms, do whatever you need to do, and you see you have the exact same variable on each side paired with a different number, you should automatically stop. You don't even need to do this step because you should be like, wait a minute, that doesn't make any sense. That's got to be no solution because it says they're equal, but they can't be equal. Like, that's impossible. The one with the 6 is always going to weigh more. Is anybody still writing here? Is it okay if I go to number 2? Okay. Nobody has an objection, right? All right, I'm going to give you a second to write this one down. And we're just going to kind of go through the steps together to simplify it a little bit. See what's happening with this one. This one's going to be another example of something that is special. We're going to see why. Your same first step is to look and see whether or not you have distributive property to do. I put a question mark because you don't always have distributive property. In this case, we do though, right? What's the clue that you're doing distributive property? The parentheses, absolutely. That 5x plus 1, so the x and the 1 won't combine because x's and 1's are racist. They won't combine, but lucky for them, their friend the 5 is going to get them out of there. So 5 times x is going to be 5x, right? And then 5 times 1 gives us a positive 5. Step 2 over on the other side of my equation. So I know I can't simplify that any more than it already is because an x and a 5 can't be combined. But do I have anything I can put together on the other side? And I'm putting a question mark because I don't know. Anything that's a like term on the left-hand side of the equation. What I got? The 3x and the 2x, correct. You can put them together because they both have an x. That gives you 5 x's. So the reason this is a shortcut, I hope, even for those of you guys who know how to solve these equations, is instead of going any further and trying to cancel anything out, you should see there's something a little bajiggity going on here. I don't know what that flash was just then. Okay, we have the same x's again. Okay, so the same number variable. In this case, this time, it's 5 x's is what we have. But instead of being paired with a different number, this time they're paired with the same number. This is no longer an example of an equation that has no solution. Quite the opposite. I'm going to show you a picture in 1 second. So now we're paired with the same number. Let me show you a picture of what 5x plus 5 looks like. I'll come back to the problem in a second. 5x plus 5. What if each one of these boxes had, let's just say they had 1 in them. So that would be 1, 2, 3, 4, 5. Plus 5 would be 10, right? 1, 2, 3, 4, 5. Plus 5 would be 10 over here, right? What if each box had, isn't this a fun little game? What if each mystery box had 2 in it? Well, then it would be 2, 4, 6, 8, 10 plus 5, which would be 15, right? 2, 4, 6, 8, 10 plus 5. This is such a fun little game. Pretend what's in the box. I could do this all day long. Would it always end up with the same amount? Yep. Yeah. Doesn't matter what x is equal to. 5 mystery numbers plus 5 is always going to be balanced out with 5 mystery numbers plus 5. So So therefore, instead of this one being an example of no solution, depending on your teacher, you will hear it called one of two things. You will hear it called option A, saying that it has an infinite. It would help if I spelled that right. Infinite, sorry. Oops. Number of solutions. In 8th grade, this is what a lot of teachers have a tendency to call it. Where does that come from? It literally means I could sit there and play that game all day long. What if X is 2? What if X is 7? Doesn't matter. It's going to balance out no matter what. 5x plus 5 is 5x plus 5 no matter what. So option A, some teachers will say it's an infinite number of solutions. Or option B, when you get to Algebra 2 here at Ballard, I know for a fact those teachers say this is a solution that is all real numbers. Yes, there are numbers that are not real. You will learn about those in Algebra 2. But for this equation, you can put any real number in there, okay? So those are our two special cases. You either have exactly the same variable on both sides with a different number, which means that one will be a no solution because it can't balance out, or you're going to have the exact same variables on both sides with the same number, which means it's always going to balance out. So you could have an infinite number of solutions or all real numbers, means the same thing. Means you can literally put any number in the planet in there and it'll balance out. Now I want to show you one non-example. So the mastery assignment you guys will have, is it okay? Wait, somebody need me to stay put for a minute? No? Okay. The mastery assignment you guys will have over this topic, which don't worry, it won't be for a minute. We're going to do lots of practice with all the different types of equations we've learned about. But when we have that sometime after we come back from our fall break, there's a problem very similar to this one on the test. That every year we've given this test 5 years in a row, and then we always miss something similar to this one. So I want to show it to you. Okay, I always like to give you those non-examples, right? So I really should call this actually a non-example instead of an example. Because a lot of people look at it and say, ooh, there's the same number on both sides. That must be like an infinite number of solutions. Or they'll say, hey, it's got the same number on both sides with different variables. So that must mean it's a no solution also. And that's not true. Okay? So I just want to point this out to you. Do we have distributive property to do in this case? No. Do we have any like terms we can combine on either side? No. So all we can do now is just isolate by getting rid of one of those variables. Doesn't matter which one you get rid of. I like to get rid of the smaller one because it keeps me from dealing with a negative number. So if I subtract 2 x's from the right-hand side, I have to subtract 2 x's from the left-hand side. So what if I have 3 x's and I take away 2 of them? What have I got left? I got an x, right? So x plus 7, that cancels, leaves me with a 7. Is my x isolated all the way yet? No, I still got to do minus 7. So x is equal to 0. So the reason you had a different number of x's on both sides, but it's still balanced out with the same number, is because x is equal to 0. What's 3 times 0? 0, right? What's 2 times 0? Still 0. So people think, oh, well, that's an infinite or a not solution because it's got the same number on both sides. It's not. That is going to be an example of x is always going to be equal to 0. It's the only type of solution that you can have a different number of zeros, but it still balances out with the same number, because obviously a million zeros equals the same amount as 2 zeros, right? 0 is 0 no matter what. So I just wanted to show you that one because every freaking year people say, oh, that's no solution. No, it's not. It's that x is equal to 0, okay? So we're going to do a little practice.